Section 4.8, Solving Equations with Fractions. In this video we will see how to solve equations with fractions by undoing addition, subtraction, multiplication, and division, clearing fractions from the equation with an LCD or least common denominator, and applications involving equations containing fractions. Undoing subtraction. We can still add the same amount to both sides of an equation without changing the solution. Example 1. Solve for x. In the equation x minus 5, 6 equals 1/3. Solution to undo subtracting 5, 6, add 5, 6 to both sides of the equation to get x minus 5 over 6 plus 5 over 6 equals 1/3 plus 5 over 6. On the left, we get x, and on the right, 1/3 plus 5 over 6 equals 2, 6 plus 5 over 6, which equals 7 over 6. It is perfectly acceptable to leave your answer as an improper fraction, if you desire, or if you are instructed to do so, you can change your answer to a mixed fraction. 7 divided by 6 is 1 with a remainder of 1, that is x equals 1 and 1/6. Checking the solution. Substitute 7, 6 for x in the original equation and simplify. So we get 7 over 6 minus 5 over 6 equals 1/3, and 7 over 6 minus 5 over 6 is 2 over 6, and 2 over 6 reduced is 1/3. Because the last statement is true, we conclude that 7 over 6 is the solution of the equation x minus 5 over 6 equals 1/3. Undoing addition. You can still subtract the same amount from both sides of an equation without changing the solution. Example 2. Solve for x in the equation x plus 2/3 equals negative 3/5. Solution to undo adding 2/3, subtract 2/3 from both sides of the equation and simplify. So we get x plus 2/3 minus 2/3 equals negative 3/5 minus 2/3. On the left we have x, and on the right, negative 3/5 is equivalent to negative 9 over 15, and minus 2/3 is equivalent to minus 10 over 15ths. Then negative 9/15 minus 10 over 15 equals negative 19 over 15. Readers are encouraged to check the solution in the original equation. Undoing multiplication. We undo multiplication by dividing. For example, to solve the equation 2x equals 6, we would divide both sides of the equation by 2. In similar fashion, we could divide both sides of the equation 3/5 x equals 4 over 10 by 3/5. However, it is more efficient to take advantage of reciprocals. For convenience, we remind readers of the multiplicative inverse property. Let a over b be any fraction. The number b over a is called the multiplicative inverse or reciprocal of a over b. The product of reciprocals is 1. A over b times b over a equals 1. Let's put our knowledge of reciprocals to work. Example 3. Solve for x in the equation 3 over 5x equals 4 over 10. Solution to undo multiplying by 3 over 5, multiply both sides by the reciprocal 5 over 3 and simplify. So we have 3 over 5x equals 4 over 10. We multiply both sides by the reciprocal to get 5 over 3 times 3 over 5x equals 5 over 3 times 4 over 10. On the left, 5 over 3 times 3 over 5 is just 1, so we have 1x. And on the right, 5 over 3 times 4 over 10 is 20 over 30, which reduces to 2 over 3, so x equals 2/3. Checking the solution, substitute 2/3 for x in the original equation and simplify. We have 3 over 5x equals 4 over 10 as the original equation. Substituting 2/3 for x, we get 3 over 5 times 2 over 3 equals 4 over 10. Then on the left, 3 over 5 times 2 over 3 equals 6 over 15. Reducing 6 over 15, we get 2 over 5. Since both sides are equal, we conclude that 2/3 is the solution of the equation 3 over 5x equals 4 over 10. Example 4. Solve for x in the equation negative 8/9 x equals 5 over 18. Solution. To undo multiplying by negative 8/9, multiply both sides by the reciprocal negative 9/8 and simplify. So multiplying by the reciprocal, we get negative 9/8 times negative 8 over 9x on the left, and on the right, negative 9/8 times 5 over 18. On the left, we have a negative 9/8 times a negative 8 over 9 is 1. And on the right, negative 9/8 times 5 over 18 factors to negative 3 times 3 over 2 times 2 times 2 times 5 over 2 times 3 times 3. 2 of the 3's cancel, and we're left with a 5 in the numerator, and 2 times 2 times 2 times 2 4 times in the denominator, which is 16. So on the right, we have negative 5 over 16, and on the left, 1x is just x. Readers are encouraged to check the solution of negative 5/16 in the original equation. Clearing fractions from the equation. Although the technique demonstrated in the previous examples is a solid mathematical technique, working with fractions in an equation is not always the most efficient use of your time. Clearing fractions from the equation. To clear all fractions from an equation, multiply both sides of the equation by the least common denominator of the fractions that appear in the equation. Let's put this idea to work. Example 5. In example 1, we were asked to solve the following equation for x. X minus 5 over 6 equals 1/3. Take a moment to review the solution technique in example 1. We will now solve this equation by first clearing all fractions from the equation. Solution. Multiply both sides of the equation by the least common denominator for the fractions appearing in the equation. The denominators are 6 and 3. The least common denominator is 6. Multiplying both sides by 6, on the left we have 6 times x minus 5 over 6, which is 6x minus 6 times 5 over 6. And 6 times 5 over 6 is just 5. So on the left we have 6x minus 5. On the right we have 6 times 1/3, which is just 6 over 3, or 2. So now we have equation 6x minus 5 equals 2. Note that the equation is now entirely clear of fractions, making it a much simpler equation to solve. So with 6x minus 5 equals 2, we'll isolate the variable term by adding 5 to both sides. On the left we get 6x, and on the right 2 plus 5 is 7. Then divide both sides by 6 to get x by itself. 6x divided by 6 is x on the left, and on the right 7 divided by 6 is just 7 over 6. Note that this is the same solution found in example 1, x equals 7 over 6. Example 6. In example 4, we were asked to solve the following equation for x. Negative 8 over 9x equals 5 over 18. Take a moment to review the solution in example 4. We will now solve this equation by first clearing all fractions from the equation. Solution. Multiply both sides of the equation by the least common denominator for the fractions that appear in the equation. So the denominators are 9 and 18. The least common denominator is 18. Multiplying both sides by 18, on the left we have 18 times negative 8 over 9x is negative 16x, and on the right 18 times 5 over 18 is 5. Now that we've got an equation with no fractions, we just need to divide by negative 16 on both sides to get x by itself. So on the left, negative 16 times x divided by negative 16 is x, and on the right, 5 divided by negative 16 is negative 5/16. Note this is the same solution found in example 4. Example 7. Solve for x in the equation 2 over 3x plus 3/4 plus 1/2. Solution. Multiply both sides of the equation by the least common denominator for the fractions appearing in the equation. The denominators are 3, 4, and 2. The least common denominator is 12. So we'll multiply both sides by 12. On the left, 12 times 2/3 x plus 3 over 4. If we distribute the 12, we get 12 times 2/3 x plus 12 times 3 over 4. And 12 times 2/3 x is 8x, and 12 times 3/4 is 9. So on the left we have 8x plus 9, and on the right 12 times a half is just half of 12, which is 6. So on the right we have 6. Note that the equation is now entirely free of fractions. We need to isolate the terms containing x on one side of the equation. We'll subtract 9 on both sides to get 8x by itself on the left and negative 3 on the right. And we'll divide by 8 on both sides. On the left, 8x divided by 8, which is just x. And on the right, negative 3 divided by 8 is negative 3/8. Readers are encouraged to check the solution of negative 3/8 in the original equation. Example 8. Solve for x in the equation 2 over 3 minus 3x over 4 equals x over 2 minus 1/8. Solution. Multiply both sides of the equation by the least common denominator for the fractions in the equation. The denominators are 2, 3, 4, and 8. The least common denominator is 24, so we'll multiply both sides by 24. On the left we have 24 times 2 over 3 minus 3x over 4. Distributing the 24, we get 24 times 2/3 minus 24 times 3x over 4. And 24 times 2/3 is 16, and 24 times 3x over 4 is 18x. So on the left we have 16 minus 18x, and on the right we have 24 times the difference of x over 2 and 1/8. We'll distribute the 24 to get 24 times x over 2 minus 24 times 1/8. 24 times x over 2 is 12x, and 24 times 1/8 is 3, so on the right we have 12x minus 3. Note that the equation is of 16 minus 18x equal to 12x minus 3 is free of fractions. We need to isolate the terms containing x on one side of the equation. So we'll subtract 12x from both sides to isolate the terms containing x. So we get, on the left, 16 minus 18x minus 12x is 16 minus 30x, and on the right, 12x minus 3 minus 12x is negative 3. Then, to isolate the variable term, we'll subtract 16 from both sides. On the left, 16 minus 30x minus 16 leaves us with a negative 30x, and on the right, negative 3 minus 16 is negative 19. We'll divide both sides by negative 30 to get x by itself. On the left, negative 30 times x divided by negative 30 is x, and on the right, negative 19 divided by negative 30 is a positive 19 over 30. Readers are encouraged to check the solution of 19 over 30 in the original equation. Applications. Let's look at some applications that involve equations containing fractions. For convenience, we repeat the requirements for word problem solutions. 1. Set up a variable dictionary. You must let your readers know what each variable in your problem represents. This can be accomplished in a number of ways. Statements such as let P represent the perimeter of the rectangle, labeling unknown values with variables in a table, and labeling unknown quantities in a sketch or diagram. 2. Set up an equation. Every solution to a word problem must include a carefully crafted equation that accurately describes the constraints in the problem statement. 3. Solve the equation. You must always solve the equation set up in the previous step. 4. Answer the question. This step is easily overlooked. For example, the problem might ask for Jean's age, but your equation solution gives the age of Jean's sister, Liz. Make sure you answer the original question asked in the problem. Your solution should be written in a sentence with appropriate units. 5. Look back. It is important to note that this step does not imply that you should simply check your solution in your equation. After all, it's possible that your equation incorrectly models the problem situation, so you could have a valid solution to an incorrect equation. The important question is, does your answer make sense based on the words in the original problem statement? Example 9. In the third quarter of a basketball game, announcers informed the crowd that attendance for the game was 12,250. If this is 2/3 of the capacity, find the full seating capacity for the basketball arena. Solution. We follow the requirements for word problem solutions. 1. Set up a variable dictionary. Let F represent the full seating capacity. Note it is much better to use a variable that sounds like the quantity that it represents. In this case, letting F represent the full seating capacity is much more descriptive than using X to represent the full seating capacity. 2. Set up an equation. 2/3 of the full seating capacity is 12,250. So we have 2/3 times F equals 12,250. 3. Solve the equation. Multiply both sides by 3 to clear fractions, then solve. Multiplying the left by 3, we have 3 times 2/3 F equals 2F, and on the right, 3 times 12,250 equals 36,750. Divide both sides by 2. On the left, 2 times F divided by 2 is F, and on the right, 36,750 divided by 2 is 18,375. Answer the question. The full seating capacity is 18,375. Look back. The words of the problem state that 2/3 of the seating capacity is 12,250. Let's take 2/3 of our answer and see what we get. 2/3 of 18,375 equals 2/3 of 18,375 over 1. Factoring 18,375 into 3 times 6,125, the 3's will cancel and we're left with 2 times 6,125 equals 12,250. This is the correct attendance, so our solution is correct. Example 10. The area of a triangle is 20 square inches. If the length of the base is 2.5 inches, find the height or altitude of the triangle. Solution. We follow the requirements for word problem solutions. 1. Set up a variable dictionary. Our variable dictionary will take the form of a well-labeled diagram. A triangle with base 2.5 inches and height h. 2. Set up the equation. The area of a triangle with base b and height h is a equals 1/2 the base times the height. Substitute a equals 20 for the area and b equals 2.5 inches for the base. To get 20 equals 1/2 times 2 and 1/2 times h. Solve the equation. Change the mixed fraction to an improper fraction, then simplify. 2 and 1/2 is equivalent to the improper fraction 5 over 2. 1/2 times 5 over 2 is 5 over 4. So we have the equation 20 equals 5 over 4 times h. Now multiply both sides by 4 over 5, the reciprocal of 5 over 4, and solve. On the left, 4 over 5 times 20 is 16, and on the right, 4 over 5 times 5 over 4 is 1. So we're left with h on the right. Answer the question. The height of the triangle is 16 inches. Look back. If the height is 16 inches and the base is 2.5 inches, then the area is what? A equals 1/2 times 2 times 1/2 times 16. 2 times 1/2 is 5 over 2, so 1/2 times 5 over 2 times 16 over 1 equals 5 times 16 over 2 times 2. Factoring into prime factors, in the numerator we have 5 times 4 factors of 2, and in the denominator 2 factors of 2. 2 factors of 2 cancel, and we're left with 5 times 2 times 2 equals 20. This is the correct area, 20 square inches, so our solution is correct.